Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuhu. This is Dr. Najam, and I hope you all are finding as we expect. In the yesterday session of the topic thermal properties and temperature 1, we discussed about thermal expansion, right? So today we will continue with the pressure volume relationship of a gas that is commonly known as Boyle's law. In the yesterday session, we already discussed about pressure temperature relationship, that is the pressure law, and volume temperature relationship of a gas, that is Charles law. So this is the third relation that we have discussed today. And if you didn't watch the video, I will share the link in the description, right? And before starting, you have to subscribe my channel and press the bell icon to get the notification of every lecture, which will improve your concepts, right? And if you want to know any particular topical content or any particular question related to the topic, so please comment below. Also share this video with your fellows. And like the video as well. And one more thing related about in this session especially, but not especially for this session, with every video you have to watch completely, then you will clear your concepts, right? So today we will discuss pressure volume relationship of a gas and temperature. So let's start. So first of all, that we talking about the pressure volume relationship of a gas, which is commonly known as its scientist name, that is Robert Boyle. So we claim that pressure volume relationship as Boyle's law. Now, what is the Boyle's law exactly? Boyle's law represents a relationship between pressure and volume, and using the kinetic model of a gas or gases, a decrease in the volume of a gas means that the number of molecules per unit volume increases. Therefore, the gas molecules collide more frequently with the inner surface of the container with greater force. And we know well one thing related about the pressure formula, that is pressure is equals to F over A, the force per unit area. That means if we are applying more force, that reflects more collision, and more collision reflects maximum pressure, right? That means pressure may affect over particle collision. So this relationship represents by the Boyle, and he also explained this phenomena on the behalf of a simple experiment. He took a setup like a container in which gas particles was filled, and then That is exactly measure the volume. Once he applied pressure, so definitely it affects. Once pressure is increased, automatically the volume is decreased and particles space is actually minimized. So we can say that V1 P1 and P2 V2. This is your initial state or initial condition, and that's your final state or final condition. So meanwhile, we can say that according to this criteria, pressure applied is exactly inversely proportional to the volume. And once we equate this, so there is a constant value K, and K is actually the temperature constant. So the formula will be PV is equals to K. Now, according to this relation, PV is equals to K. If I put the concept of this relation in my initial condition, so can I write like this? P1 V1 is equals to K, right? And P2 V2 will also equals to K, initial condition and the final condition. Because this universal criteria will be applied in every condition. So from the equation, PV is equals to K, when there is a change in pressure or volume of a gas at constant temperature as initial conditions P1 and V1 respectively, initial pressure and initial pressure and initial volume V1, and for the final condition, that is P2 for final pressure and V2 for final volume. So these two conditions as per the K, because K is common in both of these statements, temperature. So we can interrelate these two relations easily. So now combine these two equations, then what we get? So as we know, the final relation for the Boyle's law, that is P1 V1 is equals to P2 V2. This is specifically a related formula for Boyle's law, which represents their initial conditions as per your P1 V1 for pressure volume and P2 V2 for their final pressure values and their final values for. Now, if we represent the graph, the graphical representation, so how can we draw the graph? The first, we know well, that's a Boyles Law graph. First, we know that the pressure is inversely proportional to the volume, right? And remember one thing, once the quantity is inversely proportional to the other quantity, right? So हमेशा वहां पे curve बनेगा. It will be a curve. So the graphical representation between pressure and volume will be a parabolic curve. It is called a parabolic curve, right? That means this is your pressure initial, volume initial. This is your pressure final, volume final. So once we decrease the pressure value, we will increase the volume value, right? This is your curve related about pressure and volume. Similarly, if you are talking about this relation, pressure versus inverse of the volume, inverse of the volume. So we can make our graph like this. Inverse of the volume, pressure versus. So it will be like this, a straight line. This is inverse volume graph, right? Now in the both conditions, temperature is constant. There is no change in temperature. It will be fixed, right? It will be fixed. And meanwhile, again, I'm repeating, when a graph of pressure against volume is plotted, the result is a smooth curve. That means pressure and volume relation is inversely proportional. And pressure and inverse volume. Inverse volume we may also write like this. 1 over V is equals to V minus 1. Inverse volume. Inverse volume mean you may decrease the pressure, increase the volume, the same thing. It is exactly, right? So the straight line will be formed. You have to remember this curve graph. That's important. Curve wala. The first one. This one. Right? Because this graph actually represents what? The molecule exerts a force on inner surface of the container as they bounce off the walls of the container. And one more thing related to these graphs, we can clarify that if we volume halved, right? That what does it mean? It means pressure doubled. If volume is half, pressure will be doubled, and so on, right? So this particular criteria we can apply in different aspects, as the gas to be investigated is trapped in the syringe. We can also observe this phenomenon because the pressure is measured by pressure gauge and the volume is read from the syringe scale when the gas is at the same temperature as its surrounding. So the criteria would be similar as we discussed above. So this is exactly Boyle's law, and the relationship, that is P1 V1 is equals to P2 V2 according to the criteria, final to initial or initial to final. So this law is very important as per examination point of view, more than the pressure law and the Charles law, because this topical content is interlinked with the pressure as well. Once we discuss about the gas pressure, we generally consider this pressure volume relationship. Now we are talking about effect of temperature on molecular motion, right? Basically, we know well one thing, especially gases and liquids. Particles will move in this manner, random manner. And that movement is actually called rapid zigzag motion. Okay, rapid zigzag motion. And this rapid zigzag motion observation was first seen by Brownian, Robert Brown, the name of the person. So whenever we study the random motion, that means we are talking about the Brownian motion. So what we observe actually, and we can easily observe the smoke particles. So the smoke particles move randomly because air molecules were colliding them randomly, and air molecules basically are too small. So this random motion of smoke particles in air is actually represents the Brownian motion, because Brownian motion refers to the observed random movement of particles in a fluid, right? So we can simply say that about the Brownian motion: rapid and zigzag motion of particles is called Brownian motion, right? And the most important thing related about the effect of temperature actually, when the temperature of air increases, remember this, temperature if we increases, so what will happen? Average kinetic energy of the particles will also be increased, right? What does it mean? It means that average speed of the particles will also be increased, right? And if speed of the particle will increase, so definitely particle collision will also be increased. And once particle collision will increase, so pressure will be increased. So this is actually the kind of a flow chart you can say. And the effect of temperature on molecular motion, as I'm repeating again, when the temperature of air increases, the average kinetic energy of air molecules increases. This means that air molecules have greater average speed at higher temperature. So faster moving air molecules colliding, bombarded more frequently, more effectively. That means particle collision will increase. This will cause particles move faster, change their direction more frequently, and increase the air pressure. So that is exactly the criteria of the particles, and this is the best way to observe the concept of the Brownian motion. And one more thing related about the Brownian movement, that Brownian motion provides evidence for the kinetic model of matter that we have discussed in our last session, that particles are always in random motion. So this is exactly we practically observe once we examine the Brownian movement or Brownian motion. So I just write point over here. Brownian motion provides evidence for the kinetic model of matter. Right? And secondly, Brownian motion is the random motion of particles that are suspended in a fluid. Okay. And what about the effect of the temperature? When temperature increases, the particles in the fluid are observed to move faster and more vigorously. Got it? So we can say that it is proved that the kinetic model of matter Kinetic model of matter describes matter as being made up of tiny particles that are in continuous random motion. So that is exactly about the keynotes related to the effect of temperature on molecular motion, including evidence of molecular motion, which represents by the Brownian movement, zigzag motion. So I hope you clear all the topical related content. So that's enough for Brownian motion. So that's enough for today. So I hope you cleared the concept of the molecular motion. And inshallah, in the next session, we will discuss about the temperature measurement, thermometer, calibration of the thermometer, right? So thank you for watching this video, and be subscribe my channel if still you don't, and share, like this video with your fellows, and also like this video. And one more thing, if there is query, confusion, so you can comment below. So till then, take care. This is Dr. Najam signing out. Assalamu alaikum wa rahmatullahi wa barakatuh.